Hi students, in this session we will discuss about RFM analysis and how we can understand and implement it in Python in Google Colab. This is in continuation to the session we had this Saturday in which we discussed various concepts related to marketing analytics, and we also understood on a basic level how to function in a platform called NIME for those of you who were not comfortable with coding. And we understood a form of Python script which helped in RFM analysis, and we understood it on a high level. Now, the detailed working of building and implementing this analysis using NIME has already been explained in the Great Learning videos which you have access to. And that is why we did not go into much detail except for understanding on a basic level how to uh, build various tools into the NIME workflow using the node and selection, configuring them, executing them, and seeing the output, etc. Now, today we will be understanding the same in Python, and I have created for this purpose a new Python script, and this script helps us in RFM analysis and segmentation using one of the methods. There may be other methods and other customizations also available. And this script has been built for Google Colab. So let's understand it. To begin with, let's briefly go over the RFM analysis. We know that it is a powerful data-driven marketing technique to understand and segment customers on the basis of their transaction history. And it has three metrics: recency, how recently did the customer make a purchase; frequency, how often does the customer make purchases; and monetary, how much money does the customer spend. Okay, so these three are important because customers who are, visiting the store often and who have visited recently and who had made a significant contribution in terms of monetary value in purchasing their products from from the business or the brand, the products of manufactured by the business. So these are the customers who need to be focused whenever we are creating marketing campaigns or whenever we are designing our marketing strategy, right? So by scoring the customers on these three dimensions, businesses can identify their best customers, and also it can discover the customers who are not who need to be removed, who are very low on recency, frequency, and monetary. On the other end of the spectrum, you need to do that also. And then the customers who are at risk of churning, okay, who might be going away in case we don't improve our service to them or offerings to them, right? All those things. So how it has been implemented in the script is basically we have used a data set which we discussed in the session also. It is an Excel data workbook. It contains two worksheets. One is the uh, online retail, and other one is the description, right? So here we have mentioned it incorrectly that it is a .csv. It is actually a .xlsx, which is available to you, right? Now, what are the fields available in that data set is invoice number, stock code, description, which is the product description, quantity, invoice date, unit price, customer ID, and country. And this is a transnational data set which contains transactions occurring between 2010 and 2011. Okay, this is the information we have. Now, in the session wherein which has been part of your great learning module, wherein the analysis has been built on NIME, the faculty explains the RFM analysis after filtering out the country, which is basically UK. In this analysis using Python script, we have not restricted the country to UK. We have taken all the countries. That is the difference. And as you can see, unit price is mentioned in sterling, which we will be using in the analysis. Okay. Now, what are the steps we followed while building this code? First is loading of the data and preliminary data exploration, which is called exploratory data analytics. Then, wherever required, what are the pre-processing steps we needed to do, and how do we calculate the three metrics, and based on the calculation, how do we score individual customers on these three metrics, and finally segment the customers into various segments. And the last step was to see these segments in visualization. Okay. So let's start with first step. So this pip install is about upgrading to latest version of Pandas in case it has not been upgraded. This is not a required step. However, if in case you get stuck up when you are executing the code which is related to Pandas and you're getting some errors because Pandas was not upgraded to the latest version, maybe this line can help. So here I have included just for information purpose, and we can import the libraries required, which is pandas, numpy, date time for manipulating and working on the date, which is the invoice date column in this particular case. Then matplotlib and cban are for visualizations, and import warnings because sometimes we may not get an error but only warnings which we can be ignored, right? So if you use this import warnings and warnings dot filter warnings ignore, the system will not display the warnings. Okay. Now the moving on, how do we import a local PC file? We can also import using Google Drive option, and other options are there. Here using this code, when we execute it, system will give us an option to choose a local file saved on our computer. So uh, we have executed this, and this is the file online retail one.xlsx, which was stored in our local PC, and we have uploaded it here using this step. Once the full file has got uploaded, we have converted it into a data frame using the pandas pd.read underscore excel, and in this we have named the excel workbook which was imported, and we also named the sheet. If you don't mention the sheet, by default it will take the first sheet. However, we can mention the relevant sheet in case you want to import the second or third worksheet in whenever you are practicing, you can do that. So this is was just for mentioning that. And InGen equal to OpenPyXL is this is basically used for reading and working on Excel files in Python. Now this is the output of first five uh, entries. Okay, and as you can see, the various columns, a customer ID is appearing in some form which may not require, like it should appear only the number. The decimal part is not relevant here, right? That is one thing. And customer ID is, by the way, object. So similarly, we can see on the right side we have three columns: frequency, monetary, which have been included in the Excel file. But when you see the Excel file, the data is empty in these three columns. So we need to first remove these three columns, and then again we need to introduce these columns when we introduce the RFM metrics, right? So let's start with the pre-processing. First step is we are dropping off these three columns: recency, frequency, and monetary. Axis equal to 1 means it is related to dropping of columns. And in place equal to true is this permanent replacement or modification of this TTF data frame. Okay. And after doing that, if we see the output, we are not seeing those three columns on the right side. Now the second is this is the basic information about the columns which have been uploaded, and as you can see, the total number of entries as well as columns are 8, and how many non-null entries are there in each of the column, and what is the data type of that particular column or field. It's all mentioned here. So as you can see, one thing is that when you see the total records, this customer ID field has less number of non-null records than that, and also description has slightly less number of non-null records. That means these two columns have some null values, mainly the customer ID. And in RFM analysis, if customer ID has null value, we cannot progress with the analysis because it is about customer segmentation, right? So we can remove all the null values of customer ID. And for description null values, there are two options. Even if we don't delete them and keep it as unknown or impute them as unknown, still they may have customer data and the monetary value in terms of quantity and unit price. So it might still be relevant. Okay, but here we have I have chosen to delete them because they are very less in number and they may not affect the analysis adversely. Okay, but in a real time situation, you can take a call based on your business requirement. However, before we impute these null values or address these null values, I wanted you to know that because customer ID is by default saved as float, this null values are showing. We discussed customer ID should ideally be a string. So when to convert it into a string data type or object data type? Is it before removing the null or after removing the null? So I've just for learning purposes given a code here that before I address these null values, I first converted it into string, this particular field from float to string. And when I see again info, now see the customer ID has no null values. Technically it has null values, but they are not getting reflected because maybe those null values have been transformed into string and given some value, right, default. So which is not correct. So ideally if such thing happens, first you need to treat the null values and then you can convert the data type. Okay, this is just for learning purpose. So what we have done, I have converted that customer ID back into float, which was the original data type in which the data was stored, and then I have found out how many null values are there for each column using this command. By the way, we can also use is null in place of is na, and some will perform and it will add all the is na is basically a true or false. It will return every time it is encountering a null record, it will enter true. So all those true will be added and the total will be mentioned against each column. That is the purpose of this code. You can also use df.isNull and then dot sum. Okay, it will achieve a similar purpose. So now as you can see again, the description has 591 null values and customer ID has 133,359 null values. And because customer ID was stored in a float, this is the null values appearing. You can experiment before converting or imputing, convert into string and see whether null values are reflecting. Okay, which we saw it was not reflecting. Okay, now after we know these null values, we are imputing them, or in this case deleting them by using drop na. And two things are there here in the syntax. How is equal to all will say that when all the fields of a particular row have empty values, only then the row will be deleted. Very important to know. So, and in place equal to true is a final or permanent change in the df data frame. So, in our case, when we perform this and again check the null values, there is no change because the rows where description was having empty values, maybe that other columns were not having empty values. Similarly for the customer ID, that is why they did not get deleted when you use this particular line of code and how equal to all. So the other option is now how equal to any. So even if any of the column in a particular row has empty value, you will remove it. That is the purpose of this particular code. And when executed, uh, it has removed the null values in description as well as in customer ID. So now we have all the columns which have non-null values. Now we go to the duplicate entries. So df dot duplicated and then count those number of duplicates. So we can see 5192 rows are duplicate. You can also check it in Excel. The Excel file, you can use the remove duplicates command and you will get the same message 5192 rows have been duplicate. Okay, so the entire data of one row is exactly the same as entire data of some other row, and these are considered duplicates and they are not required, they are redundant, so they need to be removed in order for the analysis to be more accurate. And that is what we did, drop duplicates in place equal to true. Now we don't have null values, we don't have duplicates. I can safely convert my customer ID field into the string. But before converting, we know that when I was displaying the customer ID, it was showing a decimal point and decimal value. When you convert into string directly, the same thing will reflect in the display, the value. So we don't want that. We want an integer value to be reflecting and the string, the data type to be string. So we perform two steps. First, we converted the customer ID, which was having a float data type, to integer, as type integer. So the decimal points got removed, and then we converted them back to string. And we can, if you want, we can check out the uh, output, and you will see the customer ID modified. However, we have progressed with that performing of the descriptive statistics now. So if you see descriptive statistics, right? So here we have again broken it into three parts. One is descriptive statistics on the fields having numerical data, which is quantity and unit price. Quantity is stored in integer, unit price in float, and these will give us these measures: count, mean, standard deviation. Then the box plot measures minimum, 25 percentile, 50 percentile, which is median, 75 percentile max. Whereas if you use descriptive statistics for categorical data, some other fields might come up because box plot is not relevant or meaningful for categorical data. So that is what we have done step by step. So when we said exclude equal to object and date time, so we have excluded the fields which had having object data type and date time, only the numerical we wanted. We also introduced the percentiles, so the output we have seen. And if you see this output, the minimum value of unit price is zero. Now, when minimum value of unit price is zero and those records are present, when we multiply them with quantity, you don't get a monetary value, and that is not uh, giving us a good analysis of the customers who have purchased, right? So we will need to remove the rows where unit price is less than zero or zero, if at all it has been by mistake entered in the data. And similarly for quantity also, if suppose quantity is less than zero or equal to zero, that also does not make sense for our analysis. So we have included those two steps here. Quantity should be greater than zero and unit price should be greater than zero, and we are assigning those values to the respective columns in the data frame. Okay, now again we have performed the same descriptive analytics, and this time we see that the minimum is not zero, minimum value of unit price. Now progressing further, we have descriptive statistics of categorical field, wherein we said include equal to object and all the categorical fields, and here we are having measures of count, unique, top, and frequency, which are relevant for categorical fields. Then for the date time field of invoice date, we have done separately this descriptive analytics and seen this output. Now we start building the metrics for that. For building the metric on monetary value, we need total amount, which is nothing but quantity multiplied by unit price. So each invoice, the data has invoice number, and for each invoice number, you can multiply the quantity and unit price and arrive at the total amount, which then you can combine all the invoices pertaining to a customer so that we can arrive at the monetary value of the customer. Okay, we will see that. And regarding the recency, recency is nothing but some reference date minus the invoice date, right? So for having a reference date, we have introduced a formula here. The whatever is the maximum invoice date in that data, that plus one. Okay, and in particular this data, this is coming out to be 10th December 2011. So you can check that in the Excel. Once we have this reference, we can put that in the formula for recency. So we have two formula, one is monetary, one is recency. And for arriving at frequency, we can focus on the count, which we will do in the subsequent step. So now first we have to group by customer ID, because multiple invoices pertain to one customer, and directly counting the invoices will not yield the frequency of customers. Okay, so we have to first group by. Now as index equal to true generally has a purpose of changing the index default index to the index on which the group by has been done. But in this code, after doing this also, we are not able to see the output directly, because here we have not performed any aggregation measure. Generally group by has aggregation measures, and which we will be doing in the next step. So here we have done group by and index equal to true, and then this is the aggregation count of invoices. So all the invoices pertaining to one customer, they will be added, and that count number of invoices, then that count will be happening. So that is the group by, and as index equal to true. Now when we see the output of this, you will directly have customer ID as the index. Alternatively, if you want to change the index in green 5, by default it will be as indexes will be true even if you don't write it. But there is alternate code. We can first write as index equal to false, and then we can set index. The two-step process, that also we can do. This is just for learning purpose. But now you see that count of invoices. Focus on this. So group by. So now there are 182 invoices mentioned against, say, customer ID 12347. Do you think that means frequency is 182 of the customer ID? No, because uh, invoices can be duplicate, right? Same invoice is for one product ID, second product ID, third. So in one invoice, there might be three products he purchased, and so that invoice will appear three times because each product purchased is a separate row. So this 182 will have duplicacy, and that will not directly reflect on the frequency of the customer, right? So count is not the function we need to use. We need to have unique count. And how do we do that? We will see subsequently. Before that, this is a way of aggregation of all the three measures: recency, frequency, and the total monetary value. So wherein this invoice date, the for recency we have taken as a subtraction, whatever is the reference date minus the invoice date, okay, the last invoice date of the particular category, okay, because we are focusing on customer, right? So let us say customer has three invoices. So what is the maximum date of that invoice out of those three? That will be counted in this x dot max, and that will be separated from the reference date and to arrive at the recency value. Okay. So we have done that here. Now there are three ways of arriving at this. Here we have done count, though we know that it is not the accurate reflection of the frequency of customer. Uh, we have just reflected how we can group by these three measures. So for learning purpose, we introduce this variable here, and this is one way of naming the columns directly. Although here frequency is incorrect, and as you can see, frequency is again appearing as 182. So the same thing RFM data now 1. So focus on this particular variable for subsequent analysis, wherein we have done group by as previously, but here invoice count is on n unique. N unique is a method of counting unique invoices when we are grouping by. So let us say customer in this case. Okay. So and again I have introduced these three columns in that RFM underscore data underscore 1, which is the data frame you need to focus right now for further analysis. And see, frequency has been changed to 7. It was not 182. So there are only 7 uh, unique invoices pertaining to this customer 12347, which can reflect correctly the frequency of this customer rather than the 182, which was an inflated figure. And recency and monetary values are also reflected against each customer. And RFM2 I have just introduced here again, wherein this purpose of this particular block of code is to say how can we rename the columns of a data frame in a different way after aggregation. In the previously we just did a straight line code, simply we renamed it, and in here we have renamed it and using a different code just for learning purpose, and the output is same. So now onwards, focus on RFM underscore data underscore 1 as the data frame for our RFM analysis subsequently. Okay. Now let us start. So first we have to build scores against each of the values of RFM. Okay. So the scores can be built as 1 to 4, seeing that the bottom 25% customers, then 25 to 50%, then 50 to 75%, and top 7 at 25%. Or we can also build quintiles, bottom 20%, then 20 to 40, 40 to 60%, 60 to 80, and 80 to 100 percentiles. Okay, so here we have built quintiles. You can also do quartiles. Okay, now we know that recency metric, the value of recency metric, if it is high, indicates that there is a large gap between the reference date and the maximum invoice date. That means the customer has not visited recently. So the logic goes in the opposite sense here. So we should have a low value of recency for the score to be higher. And that is why we have indicated the order as reverse 5, 4, 3, 2, 1. And Q is equal to 5 we put, so that we want quintiles. If you want quartiles, here you put Q equal to 4, and here you put only 4, 3, 2, 1 instead of 5, 4, 3, 2, 1. That is a modification you can do. And pd.qcut is a method of introducing these quintiles so that we can convert the values into scores. Similarly, for frequency and monetary, we have done the same thing, but here the logic is ordering 1, 2, 3, 4, 5, because low frequency value means low score it should give. Similarly, low monetary value means low score it should give. And rank method equal to first, we need not write this. Generally, the following the same logic that it will go from so let us say lowest value of frequency will have first label, that is 1, and all that. Okay. So I would suggest you just remove this portion and execute the same and see whether there is any change in output. All those experiments you can do, okay, for better learning. Now one, we have now RFM values individually, and we have assigned them scores. Now, after that, we want to display them and see how it looks in the same data frame. So this is the code, and you can see RFM recency value of 2, which is a low value, so it has maximum score. Recency value of 310, which is a very high value. The date difference is very large, so recency value is very less. Okay, but frequency and monetary value, the higher the values, the higher the scores. So that is how it is getting reflected correctly. And now we want to write these scores side by side. Let us say 5, 5, 5, so that we can present the same thing to management in a easier way. Also, we want the sum of the scores. So for that, we have introduced this code, and this is just in case the scores are not integer, this will convert them into integer. So you can remove the score and check, and also if it is not working properly, because strings cannot be added, the numerical operations on strings cannot be done. So we have converted that into integer as a safety measure, and then we have done that. So as you can see here, output indicates RFM recency frequency monetary values as previously, then the scores we assign to them side by side, and then concatenation. If suppose 12, 3, 4, 7 is having 5, 5, and 5 score, the three scores are written side by side 5, 5, 5, and their sum also is computed in this column. So all these are appearing, and we also have minimum and maximum scores based on the code we have put here. Okay, RFM minimum and maximum scores, right? Dot min and dot max. The output is not in a good display because we have two, it is one below the other. For the same customer ID, we have to look below also. In order to adjust the output settings, I have introduced this code. And now we have the output in single line, which looks presentable. You can only drag this and to see the left and right, and also minimum and maximum are appearing in a different line. Now, if you want to perform on any other output, ideally, generally, you need to reset whatever settings you have done for this output using this code. Okay. Now, after we have values and their scores and their concatenation and sum of scores and minimum and maximum, now we have to segment them. One of the logic says that if the recency score is between 3 to 5 and the similarly monetary and frequency scores, then they are champion. These are the customers who are bringing high value to our business, our loyalists also, and accordingly progressively. So this is one of the ways we build the logic. We can change these parameters, and if our scores are based on quartiles instead of quintiles, this range instead of 3 to 5, you can say 3 to 4 because the maximum score is 4. Here maximum score is 5, that is why we have to put 3 to 5. So you can tweak this if your method of customization and scoring is different. And this is only one of the way of segmentation, a simple example to understand that. Okay, you can always customize it as per business requirement. Now, this is to get the outputs of different segments. Like we want customer wise scores as well as customer wise segment appearing in the output. We also want how many total champions are there out of the total customers and how many loyal customers are there. So different segments, what is the total count? That is also available using these codes. So value counts. Okay, so these two will help us know which are the customers we need to focus on. Let us say the last 90 hibernating, we need to ideally eliminate them. They are not bringing value to the business. Champions, of course, they are high value. We need to woo them more. Maybe about to sleep customers, we need to focus on this 267, which is the figure, and the potential loyalists and the potential loyalists in terms of who are right now low monetary but high frequency, and who are low frequency but high monetary, we need can focus on them also. And all these different segments customized strategy we can develop. Now there is one more way of granular segmentation based on recency and frequency scores using the if command and logic. We can use this also. It determines how we segment the customers. Okay, so this all depends on business requirement. I would suggest you tweak these values and everything and see what fits your case, right? And this is the final output based on the granular segmentation. So we have values, individual RFM values, then we have their scores, and we also have the concatenation of score and score sum for customer ID, and what is the customer ID belonging to which segment, each of the customer ID. So now we go to visualizations. So we have a segment distribution, then average recency, frequency, monetary values for each segment, characterizing RFM characteristics of segments, and other plots like scatter plot, recency versus frequency, what is there is any correlation, okay, for different segments and all that, and also tree map for segment proportion. So we can build some other visualizations to suit our requirement. So some of these visualizations are built, and this is the output we are getting. So I think this is about the RFM analysis. Hope the concept is a bit clearer to you. I would want you to work on this analysis, Python analysis. I will be sharing this file also. So work on it, tweak the values, learn it, and you will be comfortable in RFM analysis using Python. Okay. All the best till we meet again in the next session.